We start with question number 21. A rod of length L is moving on a frictionless horizontal plane parallel rails of negligible resistance as shown in the figure. These two are the rails. At the ends of the rail, a resistance R is the resistance. And uniform magnetic field B exists. This is the uniform magnetic field throughout the region. Okay, perpendicular, everything is given. If the velocity of rail is V, given there, find current in the resistance. Current. First thing, see in the given diagram to you, this extra pieces are not there. It is almost very close to the perfect size. What's my point is, even if you have extra, only the length where the circuit is complete does matters. That's the first part. The second part is that you can just a minute. Yeah. You can take a rod moving in magnetic field can be considered as a source of EMF E is equal to BLV. And if you use Fleming's right hand rule, magnetic field in V, magnetic field velocity EMF will be upwards like this, right? So this is a battery. Now, if you treat this as a battery, what I'll do, for the better understanding, what I'll do is I'll make a duplicate. This can be replaced with a battery. Got it? Yeah. As the rails are having zero resistance, no need to worry about it. The resistance will be always R. Now, this is BLV. Now, current I. They want what? Current, right? Current in the resistance. I is equal to V by R. I is equal to BLV by R. Force required to maintain velocity. What is that? See, if this current is like this, definitely it will continue, right? Like this. And it is moving like this inside the rod also. So when it is moving, when current carrying conductor is there, placed in magnetic field, try to understand the two effects. Difference is there. One is because of motion, EMF will be induced. The second one is EMF induced, current will be generated. When a current carrying conductor placed in magnetic field, it will experience force. So force is equal to F is equal to BIL. Actually, BIL sin theta. Leave it. BIL here because all are perpendicular. For this, you have to use Fleming's left-hand rule. Magnetic field. Okay, magnetic field current force. So magnetic field current is upwards, force will be towards left. Correct. Right. Force will be towards left. Clear. So F is equal to BIL. I is already there. So B square L square V by R. Answer. Question number 22. Question number 22, same diagram as the previous one. And we need to. Now, what they want? Okay. Find velocity of the rod. Now, initial velocity U is given. What is U? U is V. U. Okay, let me do one thing. I will take initial velocity as U. Right? Oh, wait. Initial velocity V naught. In the question number 22, it is given V naught. So we can take no problem. Because same symbols will be irritating. Now you can make it, no issues. U is equal to V naught. Observe, we calculate force here. F is equal to B square L square V by R. But if you want acceleration A is equal to force by mass. It will be mr. No issues. Now, once you got acceleration, observe acceleration depends on velocity. When acceleration depends on velocity, that you can say like, what they want. They want velocity as a function of time. Okay. A is equal to dv by dt is equal to v square L square by mr into v. So what I'll do, I'll take dt on this side and I'll bring v on this side. dv by v is equal to b square L square mr into dt. Integrate on both sides. If you integrate, what is the value? Integral dv is what? Ln v is equal to b square constant, L square constant, m also, everything is constant here. Integral dt is equal to t. Okay, it changes from what, tell me? V naught to v. That implies ln v by v naught is equal to b square L square by mr into t. What I'll do is that I will that implies I'll take e power on both sides. E power ln x is equal to x, right? So e power ln x means e power v by v naught is equal to e power this entire value. See, when you're writing a large value in the power, it's irritating. So we can write another way also. Entire thing can be written as exp. Do you remember? Do you know this? Exp means exponential of b square L square by mr into t. Okay. So if you want, you can make it. But anyway, it's a big blunder I did in this. Blunder I did. That is, acceleration and velocity are opposite in direction. Forgot.
Minus sign.
Minus sign must be there. Okay. Okay. Final answer will be V is equal to V naught exponential minus B square L square by MRT. This is the answer. Part B, anyone? At least if you can find how to solve, that's enough. You just say that, how to find. Sir, I'll find part B in this way. The method, what you think is then? Sir, I know velocity. Once I know velocity, I can calculate current. Once I know current, this current is flowing through. When current is flowing through, heat liberated, Q is equal to, I think, power is equal to voltage into current. Power into time is the heat liberated here, right? VI or I square RT. So what, because it's a variable, dq, small amount of heat liberated in a small time interval dt, then I'll integrate on both sides and I have to substitute the formula of V here. Definitely you can do it. If you want, you can do it. But there is another method. Shall I? You can see that the rod will slow down and come to rest, right or wrong? So initially rod is having kinetic energy half m v naught square, right? So this is the heat liberated. When the rod is having half m v naught square, that's the energy. As the rod goes forward, it is decreasing its energy and it is the energy is liberating in the form of heat. So total heat liberated will be half m v square answer. Half m v naught square directly you can say answer, you don't need to solve. Okay, half m v naught, that's it. Sir, if I solve in this way, Do I get the same answer? 100% yes. If anyone interested, we'll check it. Otherwise, we don't need actually. You can go ahead. Shall I check? Yes or no? Anyone?
Yes.
Yeah, we'll check it. Right. So Q total heat is equal to I square R. Sorry, I did a mistake. I square. Okay, I'll continue with it. I square R. So R is R. I square. What is I square? I is BLV. Check it. BLV by R. I square R will be B square L square V. V square. V square means this value, right? V naught square exponential minus 2B square L square by MRT. What I did is that e power some x whole square, I took it as, right? Any problem?
No, sir.
Okay. Wait a minute. V naught by R square. And what I did is that the constants I took it out. Only variable I have. R square gets cancelled. That is equal to only this part I'm integrating. What is the value again? E square L square V naught square by R into exponential e power x. Integration is e power x only, right?
Yes, sir.
Power x, but by this entire thing will come, right?
Minus
2b square L square by m R.
with the minus sign,
Minus
sir.
m, yes, minus m will be there. Now, if you observe, b square L square gets cancelled. R gets cancelled. It goes to numerator. Half. This is the 2. Multiply with this entire value. Minus n is also there, right? Minus. Now, heat will be liberated. Total heat means what? Finally means time t is nearly equal to infinity. So that's 0. If you take t is equal to infinity, it is 0. You check the boundaries. What do the boundaries tell me? 0 to infinity. Sufficiently long time of infinity we take. When I put 0, e power 0 is equal to 1. Okay. E power 0 equal
Understood.
to, right? And the finally you'll end up at 0 minus 1. So what the heat liberated?
Half M.
Anyway, you will get the same answer. Doesn't matter. Okay. Question number 23. Question number 23. Yep. Observe on this rod, definitely tension T will be acting. Tension T will be acting, and backward because of magnetic field force will be there. Force value we calculated here already. Check it. B square L square V by R. So force B square L square V by R must be equal to tension T. Reason? Now there is no acceleration. Velocity is constant. That's fine. Now let us write the free body diagram of this one. Upward tension T. Upward tension T. Downward is mg. Okay. Once it is then observe, because it's moving with constant velocity, that's a terminal velocity logic. We can say a T must be equal to mg. Now equate them. Let us call this velocity as terminal velocity Vt is equal to mgr by b square L square V. This is the terminal velocity. Sir, can I V? You V बराबर. Sir, can I reach this terminal velocity in another way? Yes, there is another way. We already derived a function for V, right?
Yes, sir.
Oh wait, this is V naught, no? Sorry, we have some velocity V. It doesn't apply to. We have to write the equation for V and integrate. Lengthy. I'm not going to solve right now. Just leave it. We can derive it actually speaking. You can derive terminal velocity also. Okay, go ahead with the next question. 24. This is a bit tough one and a good one also. Yeah, actual diagram is three-dimensional. It's difficult to show you. So I'm giving you perfect side view. This angle is theta, and the rod looks like a, maybe assume this is a cylindrical rod. Okay, assume that it's a cylindrical rod. So it looks like a side view will be like this. So if you take x-axis along horizontal and y-axis along vertical, z will be perpendicular to it, and the rod will be along the z. It is out of the plane or into the plane. You need to understand that one first. Okay, fine. Then what next? Who's pulling it down? No need to discuss. Mg what? Mg sin theta, right or wrong? Mg sin theta. Normal force, yeah, perpendicular direction, I don't care. Just leave it. Okay, let us continue. A rod of length L, mass M, released from rest and frictionless parallel. Uniform magnitude. Terminal velocity. Terminal velocity means what? Mg sin theta. Good, that's fine. Mg sin theta is the force which is acting. There must be a force which is pulling upwards. Don't blindly take it like this. The force may not be exactly like this. It's some other angle may be there. The component also possible, right? So we have to be a little careful here. Let us calculate the direction of force. Observe V and B. B is vertically downwards, right or wrong? Check it. Vertically downwards. B is not a problem at all. Just a minute. I think direction wrong. B is vertically downwards. Yeah. B is now I can take B is vertically downwards like this, and then I can continue. Leave it. Yeah. B is now if you see velocity V will be like this. So V cross B, if you can feel the right hand thumb rule into the magnetic field, it's like this perpendicular magnetic field. Sorry. So V cross B will be perpendicular to it, and I can say it is along this line. EMF will be in this line. So when EMF is in this line, current will be like this. Can you understand this? So this is the direction of EMF, EMF E, or I can treat like this. This is the battery, right? Or you can use Fleming's right hand rule. But the problem is velocity V and B are not perpendicular. So you can't use that, but you can take component of velocity like this and you can deal, or component of magnetic field also okay. V cross B. So EMF E is equal to BLV sin theta. B is B, L is L, P is V, BLV sin theta, sin of angle between them. What is the angle between them? 90 minus theta, right?
Yes, sir.
Cos theta. That's a EMF. Now, if I got the EMF, divide with R, you will get what? Tell me. Current.
Current.
Once you got the current, you can find force. F is equal to BIL. F is equal to BIL. So force F is equal to B into I into L. So what I can do is that directly I can, this is I, na? I'll multiply with this I. I have to multiply with B and L, right? If I multiply, what happens? B square it
L
becomes L square, nothing else. That's fine. Just a minute. That's it, nothing else. I got the force, but again, the force will be Fleming's left hand rule I have to use. Observe magnetic field, right? Current, force. Yeah, I can't show you my fingers, but magnetic field is downwards, magnetic field. Current is into the plane. If you observe the force, that's the key thing. Force is horizontal. Right?
Sir, can you explain once again, sir?
Which one? This force horizontal.
Yes, sir.
But the problem is that's what I'm thinking. How can I explain? Do you know? See, when you have a current carrying conductor, when you have a current carrying conductor in magnetic field, assume that rod like this is there. Magnetic field is inwards. Current is like this. There will be force, right or wrong?
Yes, sir.
How to find? You have to stretch your index finger, middle finger, and thumb perpendicular to each other of left hand. Keep the what index finger in the direction of magnetic field. Rotate the fingers until you get the correct orientation. If you observe, force will be like this. Do you remember this?
Yes. Yes, sir. Understood, sir.
Yeah, that the logic I'm using. Okay. Now I'll explain. F is there. Now this F is not completely opposing mg sin theta. The part, the component you need to take. The component will be F cos theta. This angle is theta. So F cos theta. So that is it. That implies this F cos theta must be equal to what? Mg sin theta. So I'll write the equation. Terminal velocity condition I'm telling you. So that implies leave it. I don't need to write implies. Directly write F cos theta. So this is F. I'm going to copy this F cos theta must be equal to mg sin theta. So this velocity is terminal velocity. So let us call it as Vt. So if that implies Vt is equal to mgr sin theta by b square L square cos square theta. So generally student will miss something sin theta or cos theta somewhere. Somewhere they take they forget to take the component generally. Right, that's a very common thing for us. It's okay. You cross check what mistake you did. Next one. This is 24, right? What about 25? Actually, this is 25 is as good as 23. The thing is that here mg is pulling and rod is massless. The rod itself has mass. Same answer you will get. Final answer is V naught by 2. Ipudi conservation momentum. Initial total momentum of the system is m into V naught. Final momentum is m plus m. Both are moving together. V. So V is equal to V naught by 2. Answer.
Sir, but here we have a force acting in the direction of the velocity. Right?
I'm taking them as single system. Those two are single system.
Oh,
The
okay,
force,
okay,
force
okay.
becomes internal. खेल खत्म, दुकान बंद. Over. Why should they move with same velocity? Right? Okay. That's a good one.
Change in process.
I'll tell you. First of all, when it is moving like this, will you accept it generates EMF like this?
Yes.
This EMF will induce current in what direction? Yes or no? Now, Fleming's left-hand rule, magnetic field, current, force. Wait.
Sir,
V cross
opposite direction.
opposite direction. Absolutely wrong idea.
So this is induced.
Induced EMF will be Fleming's right-hand rule I have to use. I use left-hand rule. So magnetic field motion EMF will be like this.
Sir,
So
left hand rule only we should use.
initially to find EMF direction like this now. For EMF, we have to use right-hand rule. Force, left-hand rule. Both we need to use here. Okay? Right. So it's like this. The current will be. Are you convinced with this part at least?
Yes. Sir.
Now, once you convinced with this part, remaining things we can deal. Current is I. Because of current, magnetic field, current, force will be backwards. And what is the force on this? Magnetic field, current, force. Can you see that?
Opposite direction.
Yeah. So force magnitude wise, it must be equal. You want me to prove that both are having equal magnitude or convinced? Yeah.
And then
F is equal to BIL, B is same, I is same, L, I must be same L. So observe velocity of this, sorry, force on this will decrease the velocity. Force on this will increase the velocity. There will be a stage where the velocities are equal. But I can't conclude they'll stop there. That's also a very good point. I can't conclude they'll stop. Okay. So how to deal with it? I'll explain. When the velocity is decreasing and the velocity is increasing here, when they reach common velocity v naught by 2, then the force becomes 0. Why? Both are moving with same velocity at this moment. Because I told you already. When velocity is same, potential difference will be same. Both will generate same potential difference, right? Like this. Then current becomes 0, cross check it. Or I can say one thing. Because of this one moving like this, it is adding extra flux. Yes or no?
yes, sir.
This is also moving the same distance, same velocity. So it takes out the same flux. So the loop will have same constant area. So velocity is constant. It doesn't change. Right? So let's calculate this. Definitely there will be downward mg. Downward mg. No need to discuss much. There will be upward force due to magnetic field, right? FB. Now acceleration must be equal to mg minus FB. What is FB? FB is equal to F is equal to BIL. Correct. That implies that is equal to mg minus BIL. That's fine. That's the net force. Must be equal to mass into acceleration. Perfect. That's good. Now, what next? Observe carefully that I is required, right? I is equal to EMF by resistance. EMF EMF is equal to BLV by R. Yeah, I can substitute there. So mg, that implies mg minus b square L square V by R is equal to ma. Right? Okay, that's fine. But how to get the acceleration there, right? Now I'm not able to find a relation there, right? Anyone can help me out right now in trouble? Okay, shall I explain? Okay, I'll explain. See, this is fine, but one thing is clear. Whatever potential difference is there, same potential difference must be here. So BLV must be equal to, what is the formula for potential difference across the capacitor? Q by C, right? That implies differentiate. BL dV by dt is equal to I by C. Will you accept it? Okay, instead of writing I by C, dq by dt into 1 by C. Clear? Now this is I, this is A. Oh, there is a relation between I and A, right? So BLA must be equal to I by C. Wait, you don't need to use this one. Directly you can use this equation here, right? So use that equation. I is equal to BLAC. So EMG minus B into BLAC into L is equal to MA. I'll bring it on this side because A is there. That implies MG is equal to B square L square C plus M into A. Implies A is equal to mg by B square L square C plus M. What's the key point you need to understand in this case is that, see, I'm not at all feeling anything. Blind formulas I'm using. That's how I'm solving it. So